Okay, some things that we know from our periodic table. We've established what our group names and numbers are. And then we've also established what our valence electron counts are for this regular 8. And just to remind you, you should have these on your periodic table that you have 1 valence electron here, 2 valence electrons here, 3, 4, 5, 6, 7, and 8. So that should be marked on your periodic table. And then we're also getting into where we start understanding about the cations and the anions. So we have cations, which are going to take on a positive charge, and these are going to be your metals. And so for group 1, it's easier for them to lose 1 electron and become +1 charge. It's easier for group 2 to lose its 2 valence electrons and take on a +2 charge. And group 3, it's easier to lose 3 than it is to gain 5, because the objective is to get to 8. We're going to skip group 4 because they're just odd. And then we start our anions. And these are negative charge ions. These are generally going to be your nonmetals. So starting with group 5, my goal is to get to 8. 8 minus 5 is 3. So this is a -3. Group 6 is a -2. Group 7 is a -1. And just to clarify this, group 8 is a 0 charge, because they're very content and very happy where they're at, because they have a full vocab word, octet, which makes the noble gases, we say, inert. So those are some things we should know. Okay. Now, what one of the things I'll be asking you to do is be able to take this information and start answering various questions with it. So one example of what I can do with this knowledge that I have now is I can figure out my protons, neutrons, electrons. So here I have this handy dandy worksheet, and I'm going to start first by highlighting things that I already recognize. So my proton count is the same thing as my atomic number count, and that number that I get for there identifies the element. And as long as we are at ground state, or no charges, so as long as I'm working with a neutral substance, then whatever my proton or atomic number count is, that is also my electron count. So let's do this. So the first symbol is boron. I go over here to boron. There's my atomic number in the corner, 5. And so my proton count is 5. My atomic number is 5. My electron count is 5. Now, how did they get the neutrons for 6? Well, if I look over here, I'll see this number here. Well, I can't have part of an atom. So basically what we did was we rounded this 11. We said 11 minus 5 is, and that gives me the happy number 6. So my neutron count is determined by taking the AMU minus the atomic number. And that's my neutrons. My atomic mass, if you recall, right, that's going to be my number of protons and my number of neutrons added together. So 5 plus 6 equals 11. Let's do another one. This one they gave me the atomic number, so as soon as I see that number, then I know that that's going to be my number of protons here and my number of electrons here as well. Go to my periodic table, I'm looking for number 11, and I find it. It's sodium, Na. So my symbol is Na. Now, it says that the atomic mass is 24. So 24 minus 11 gives me my neutron count, which is 13. And that's my number neutron count there. Let's do one more example. Let's do this one right here. So it says the atomic number is 100, so I know that's going to be my proton count and my electron count. So I'm going to go to my periodic table, and I'm looking for 100. 100. Toot, toot, toot. I find it right there. So it's FM. Once I have that, then I'm going to add these two together. So 100 plus 259, 100 plus 159 equals 259, and that's my atomic mass unit. Go ahead and try the rest of them and see how you do.